All right, so this session is on using the Vertex formula. So this goes with the first homework that you're doing, which is dealing with quadratic equations. But this is also going to be very helpful for next week's discussion, because in week 7 will be it'll be another math-based discussion, and you'll be using the Vertex formula for that. So this is going to be very helpful for that discussion. So if you watch my video that's in the classroom already on quadratic equations, some of this is going to be familiar because some of the explanations are going to be similar, but all of the examples are going to be different, and they're going to be geared towards using this Vertex formula. So we've been talking about functions, and we've been focusing on linear things up to now. Now we're moving on to polynomials, and a quadratic is a specific type of polynomial function. So it's a function, which means for each input there's only one output, and a quadratic is particularly where it has an x squared on it. So we did solve quadratic equations. Now we're going to be focusing on them from like a graphing and function perspective. And they form basically a U shape, which is called a parabola. And the basic form of this is just f of x equals x squared, and then you have things that are added or subtracted to that can affect the shape. When we're looking at it from a graph, the center is the axis of symmetry, and that's upon where it makes a mirror image. So if you split it in half so it has a mirror image, that line is the axis of symmetry, and then the point on the graph at which it is the halfway point, that's called the vertex. So that's basically the middle point of the graph. And so for our basic function here, the vertex is at the origin, and then it's opening upwards for f of x equals x squared. So there are two main forms of a quadratic function. We've got standard form, where it's ax squared plus bx plus c, and this is the kind of form you saw when we were solving quadratic equations. And then we've got vertex form, which is it will make the same graph as its standard form version, but the numbers in it give you the vertex. So standard form is good if you're trying to find the y-intercept, because that number c, or that whatever is just added on the constant, that's your y-intercept. And it's useful for finding x-intercepts because you just set it equal to 0 and then you solve. Vertex form, you can also find the y-intercept, though you do have to do a little bit more math. It's very easy to find the vertex with it. It's easy for finding the axis of symmetry, and then it's actually a lot easier if you're trying to graph things by hand. So each type of equation has its, what it's useful for, which is why we have multiple forms. And to go from standard form to vertex form, you have to complete the square, but we're not going to focus on that because that's not used too often. So we're not going to work on actually going through that process. What's important is understanding the different forms and what information they give you. So when you have vertex form, that what's in parentheses x minus h, whatever you're subtracting, that is the x value for your vertex, and then whatever you're adding on, the k, is the y value of the vertex. So you can read the vertex directly off of this equation. Then the number that's in front of your squared part, that tells you whether it's opening up or opening down. If it's positive, it opens up. If it's negative, it opens down. And then based off of that, that also tells you if your vertex is going to be the minimum or the maximum value. If you're opening up, then the vertex is the minimum value. And if you're opening down, then the vertex is the maximum value. So sometimes, and this is where it's really useful, is you'll be told to find the maximum of something or the minimum of something. And if it's a quadratic, what it's asking for is the vertex. And then the axis of symmetry is just the equation x equals h with whatever that x value is for the vertex. So if you have something that's not in vertex form, then we actually have the vertex formula, which allows you to find the vertex without having to go through completing the square. And these formulas come from completing the square, but I'm not going to show that because it's not really important. What's important is the formulas. So the x value of the vertex, which is h, is negative b over 2a. And that might look familiar because it also sort of comes from the quadratic formula. And then to get the y value of the vertex, so I can, this is the x value and the y value. You plug your value in, so this is basically just f of h. You just plug your x value into the equation and get the y value out. And so you find your y value negative b, or your x value negative b over 2a, plug it into the equation, and then this gives you an ordered pair, and that's the vertex. And that's what you're going to be doing for your discussion for next week. Is you're going to have an equation, and then you need to find the vertex. So you're literally just using these two equations basically. So let's just get into using this, finding the vertex of a parabola. So on the left, I've got g of x equals 4x squared minus 64x plus 107. So our vertex is an ordered pair h comma k. And h is negative b over 2a. So we need to determine what those values are in our equation here. So we've got the number in front of the x squared term is a, so a is equal to 4. The number in front of the x term is b, so b is equal to negative 64. And then the number that's added on is c. So these are the same a, b, and c that we use with the quadratic formula. But as far as finding the vertex, that number that's added on c doesn't matter. All we care about are a and b. So we just plug them into our formula here. So we have negative b, and so b is already a negative. So it's a negative 4, or negative 64, I mean. And then 2 times a, so that's 2 times 4. So we get 64 over 8. And so this gives us h is equal to 8. So that's the x value for our vertex. And then we need to find the y value, which is k. And so that's where you plug it into your formula. So k is equal to g of h in this case. So I'm plugging, this is going to be g of 8 because h is equal to 8. So we need to plug this into our formula. So I have 4x squared. So x is 8. Going back to our functions that we learned about last week. So that's going to be 8 squared minus 64 times 8 plus 107. And then we're going to be following the order of operations to simplify this expression. Now, one thing that you're going to find very helpful is actually utilizing a graphing calculator to help you out, or even Desmos. So I'm actually going to pull Desmos up. And so we're going to just look on this left side. I don't actually care about the graph, but we're going to just make our calculations here easier. So I'm going to type in my equation that I have right here. And I'm going to just type it exactly as I see it. So if it's g of x, I'm going to type in g of x equals 4x. And then I'm going to go up into the exponent. The shortcut is Shift 6. And then I can go squared, and then I have to hit the right arrow to get out of the square. Minus 64x plus 107. Now that's going to graph it. We don't really care what the graph looks like. What we want is the vertex, and I want to figure out what does this equal, because this is, I can put this all in my calculator. But once you find out what h is, we know that h is 8, so g of 8, you can just type that in a Desmos and then it gives you your number out. So this 4 times 8 squared minus 64 times 8 plus 107 is going to give us negative 149. And so you can do that on your calculator, but this is just a lot easier, you don't have to make any mistakes here, because you can plug it in. Now, if you're doing this on a quiz, what you want to do is you do want to show this step that I've written down, but then you can just have Desmos up, type it up, instead of typing it into your calculator. But you do want to at least show what number you're plugging in here. So this comes to negative 149. So now we have our h and our k, and so our vertex is an ordered pair. So our vertex is the h value, 8, and then the y value, which is negative 149, or h comma k. So your final answer is not just two separate numbers. You're writing it as an ordered pair, because that's what the vertex is. The vertex is an ordered pair. Are there any questions so far? Okay. So let's look at the example on the right, and I picked this one because it does have a fraction in it. So let's start with we want to find the vertex. So h is negative b over 2a. I'm going to just kind of draw a line here. So a in this case is negative 1/4, and b is 10, and c is negative 5. So negative b, and b is 10, so that's going to be negative 10, or 2 times negative 1/4. So when you have a fraction in the denominator, you're basically dividing by that fraction. That's the same thing as multiplying by the reciprocal. So this is the same thing as 10 over 2 times negative 4 over 1. Because when you're dividing by a fraction, it's multiplying by the reciprocal. And so this makes it actually a lot easier for us to simplify. So we've got a negative and a negative. Those cancel out. And when you multiply across, you're going to get 40 over 2, which then 40 divided by 2 is 20. So we're going to get 20 for the first value of our vertex. And then we want to plug that value in to find k. So k is going to be f of 20 in this case. So you're plugging 20 in for t. So you want to make sure when you're writing this that you are correctly plugging in the number. So everywhere I see t, I'm going to put 20. But let's just use Desmos to do this calculation for us, because it will just make your life a lot easier. So unfortunately, I can't. Let's see if I can. Here we go. So I can just X these out, and I want to type in. Oh, I misread. I have a J here instead of an F. My J, I read it as an F. This is actually J of 20 here. So J of, and you can use T here and it will be totally fine. So negative 1, and if you use the slash, that will get you into the fraction. Then I gotta make sure I hit to the right so I get out of the fraction. T squared plus 10t minus 5. And then we want J of 20. And so this math is going to come out to 95. And so that gives us our vertex as 20, 95. And you can check your work in Desmos. So I'm going to just zoom out and then click and drag here. So you can see the vertex in this case is a maximum. And when I click on it, it actually has a dot right at that location, and it gives you the ordered pair, which matches with what we found with our formula. So it comes out to 20, 95. So are there any questions so far? Okay. All right, so 2 more examples here, and then I've got a whole bunch of word problems, because those are really where you're going to be using the formula, where it's going to make sense. So on the left here, we have h of a equals 2a squared plus 14. So in this case, we don't have a middle term. There's no middle here. There's no a. So when we're trying to find our vertex, first off, we figure out our numbers. So, and actually, we have to be very careful that the a we're talking about is not the same as that variable a. So we're just caring about the number that's in front, which is 2. The number in the middle, if there's no number there, it's 0. And then c is 14. So sometimes there is no middle term, and so your b is 0. So for the vertex, it's negative b over 2a. So b is 0, and we'd have negative 0, which is still 0. And then 2a, and a is 2, so that's going to be 2 times 2. So just as a good arithmetic practice here, what does h equal when you do this math? You can go ahead and type it into the chat. Zero. So 0 divided by anything is 0. So h is going to be 0. So now we need to find k, which in this case is going to be h of 0. Again, it has the letter h as the name of the function. And so in this case, this h is not the number that we just picked. We're referring to the function name. So that's something that can get confusing with math. And so sometimes it might be useful to maybe color code. So, you know, maybe say, okay, when I'm referring to the function, maybe I'll do that in blue. So maybe this h will be blue because it's the function. But when I'm referring to the vertex h, maybe that's in a different color, that's yellow. Or maybe let's say maybe we make that one green, just so you have 2 different colors. And you can do the same thing with the letter A if you're getting kind of confused here. As you can say, okay, maybe that letter A is going to be orange, and then the A that we're using in our formula is, I don't know, going to be purple or something like, or this A is going to be purple, or whoops, not cool. Oh, I could use green because those are, no, because let's make these, I can make green the vertex, but just if you know, maybe color coding so that you don't get confused that they're the same thing, because in one, the orange A is referring to the variable A in the equation. The purple A is referring to the coefficients in front based off of our standard form. The green H is referring to the H of the vertex, but the blue H is referring to the name of the function. So that is something that can get confusing when you have formulas, because sometimes the variables in the formula can be used as other things in an equation. And so color coding can kind of help you keep track of that. But at any rate, so we're trying to find h of 0, which means we're plugging 0 into our equation. So instead of a, we have 0. So when you do this math, and I'm not going to bring up Desmos to do this. This one is something that you can do pretty easily. You can even do it without a calculator here. What is k going to be equal to? And you can go ahead and type that into the chat. 14, that is correct. Because 0 squared is 0, 2 times 0 is 0. So all we'll have is 14. And so our vertex is going to be 0, 14. So moving on the example to the right. So on the right, we have decimals. And when you have an equation with decimals, you're allowed to give your answer in decimals. So if there's decimals already in the problem, you can give your answer as a decimal. You don't have to convert it to a fraction or anything like that. So because Q of X is in decimals, we can use decimals in our answer. So what I want you guys to do is actually to find both h and k for this problem. And feel free to use a calculator to help you with k, especially with those decimals. You can use Desmos, but I want you guys to try to do this complete problem, and then you can type your answers into the chat, and I will then put the answers up myself. But I want to give you guys some practice before we get into the word problems. If you want to give your answer for H first and then your answer for K and then together as the vertex, that's totally fine. So we've got one answer of 0.15 and 4.48. I've started writing the work for H on there. I'm just going to now throw it on my calculator. So yes, H is 0.15. That part is correct. Give you guys some time, give other people time to do K while I'm going to write this out. So if you plug in 0.15 into the function to find your K, with more decimals, you get 4.58125. That's I put that into Desmos. Once I found H, I put in the function and I did that in Desmos, and that was the number of decimal places that Desmos gave me. And so based off of your rounded, you can say 0.15 and then 4.58. Since you have 2 decimal places for the 0.15, you then can use 2 decimal places for 4.58. So that's completely valid. Otherwise, what some people do is maybe round to 1 decimal place because your lowest number of decimals is 1 decimal place here. If you've taken a chemistry class, that would be what they call significant figures, is that they go with the lowest number of decimals. So since we've got a 7.5 with 1 decimal place, if you round it that way, you might get 0.2 and 4.6. In math, we usually go with the largest number of decimals, so it's sort of the opposite of chemistry and math and like science classes. So we would use 2 decimals because that's the most number of decimals we have in our problem here. So we would round to 0.15 and 4.58. Now, when you're doing this kind of stuff in ALEKS, they will tell you how many decimal places to use, and they'll say round to 2 decimal places, or they might say round to the nearest 100th, which is 2 decimal places. So you do want to pay attention to that, and the general rule is to round at the very end. Don't round at the very beginning. Like, so you wouldn't use 0.2 in this equation right here. You would use your original number and then round at the very end, because that way you're less likely to have issues, because if you round too many times, your answer can get too far off, and then ALEKS doesn't know that you have the right answer because it's too far away because you rounded too much. So the basic rule is use as many decimals as possible until your final answer, and that's where you round. Are there any questions on that? Okay, so now let's get into the word problems. And this is, I know it's going to be a little small, I'm going to read it out loud, but this is where this stuff is useful for those of you who are in business. So I know a lot, so if you're in like in business administrations, you have to go and take, like, I think there's macroeconomics and microeconomics. And those courses require college algebra for them, if I remember correctly from the catalog. And the one thing you'll learn in those courses is that you have like supply and demand curves, and sometimes those curves look like parabolas and we form quadratics. And so you can then find the maximum, like where you maybe have the maximum profit, like in this example, or you want to find, you know, where the demand is maximum. So that way, you know, what is the price that I can sell my product at that will have the maximum demand, you know, those kind of problems. And so you need to actually know how to work with quadratics, because that's how you find maximum. So this is actually something that you may see. You'll see these types of curves in an economics class. So those of you going into business, this is something that is going to be helpful. So this example, and these are examples from the textbook, the monthly profit for a small company that makes long sleeve t-shirts depends on the price per shirt. If the price is too high, the sales will drop. If the price is too low, the revenue brought in, it may not cover the cost to produce the shirt. So this is one of the things you talk about economics, is you're trying to find the best price. So after months of data collection, the sales team determines that the monthly profit is approximated by this equation. So we have f of p equals negative p, or negative 50p squared, plus 1700p minus 12,000. Now in the real world, your numbers are not going to be whole numbers like this, but this is something that you can do. Like, let's say you have a small business and you set the price for a t-shirt at a certain price for a month. Then the next month you try a different price. You know, maybe you put it on sale or something like that. And you do this and you collect data, and then you see, well, how many shirts did I sell at that price? And then you basically have like an Excel document of data, and you can use Excel to then graph that, and then you can do what is called interpolation or regression. And Excel can actually, you can tell Excel to make a quadratic formula, especially if you're going to have a curve where it doesn't look linear, but it looks like it curves. So you can tell Excel, okay, find an equation that best fits my data. And then that will give you your equation, and then you can use that to find your the price that generates the maximum profit. So this particular problem, the numbers are just nicer to work with, but in real life, this is exactly what you can do. You can get the data, put it in Excel, and you can actually get a quadratic equation. So we're just going to work with these numbers. P, which is the input because it's F of P, so P is the price per shirt. So your input, what you are setting is the price per shirt. And then in this case, F of P is the monthly profit. So in this example, they're looking at, well, how much money did I make at that price versus how many did I sell? But you can make one for how many you sold. So part A says to find the price that generates the maximum profit. So if you are given a quadratic equation and they are telling you to find the maximum or the minimum, they're telling you find the vertex. As soon as you see those words, it means find the vertex. So we have maximum and maximum. And so you don't have to care if it says maximum or minimum or whether your vertex will be a maximum or minimum, because they'll give you the equation and the wording will match that. But those words tell you, okay, what I'm doing is actually finding the vertex. And the x value of the vertex is one answer. The y value of the vertex is the other answer. So you're giving it in two different pieces here rather than just giving an ordered pair. So our vertex, oops, still in the highlighter, I want the pen. So our vertex, which is H comma P, our input is the price per shirt. So I like to label that, so when you find the vertex, you know whatever that number is. Oops, somehow I accidentally changed the slide. Didn't even notice that. Okay, well, let's try this again. HK. So it's the price per shirt. So I like to label that so I know whatever the number is, what that number means. And so our input is the price per shirt because they actually tell you that. So these labels are coming directly from what's in the problem. And then F of P is the output, that is the monthly profit. So K is the monthly profit. So it's nice to label these things because then you know which number goes in part A and which number goes with part B. So I just start off with labeling that, putting it into the words that are in the problem so I know what I'm looking for. So first we want to find H, which is negative B over 2A. So B is the middle number in our equation. So I'm going to just rewrite our equation a little larger here. It's negative 50p squared plus 1700p minus 12,000. So B is the 1700. So this is going to be negative 1700 over 2 times A, which is negative 50. So you want to make sure you're paying attention to the negative signs. You're not forgetting any negative signs. And the nice thing about word problems is that you get an idea of whether your answer makes sense, because if I got a negative answer for my price per shirt, that doesn't make any sense. So if you get like a negative, that can tell you, oh, that can't be right. Let me double check my math. So we can just put this on a calculator. And this comes out to 17. So this is the price per shirt. So this is what is part A. It says find the price that generates the maximum profit. That's this number here. So the price per shirt would be $17 to get the maximum profit. And we should always give our answer as a sentence because this is a word problem. And so you want to put it in context. So what you would say is that selling at $17 per shirt maximizes the profit. So Alex is not going to ask you to write a sentence, you know, they'll just ask you for the number, but for your own notes, it's really good to write a sentence so that you know what this means that you've just done. And then we want to find the maximum profit. So that is going to be K, which is going to be, we're going to be plugging in 17 into our function value. So it's going to be negative 50 times 17 squared plus 1700 times 17 minus 12,000. And let's see who wins. So if you are faster with your calculator than I am, you can type that into the chat. Some of you might have already been working ahead to solve this. I get 2,450. Good. Somebody else got the same number. So it's always good to have a second check and make sure that we didn't mess up here. So if we put this in a sentence, we would say the maximum profit is $2,450. And so that would be the maximum that you would make in that month if that is what your sales price would be on a t-shirt. And you can always check your work by putting your picture or your equation into Desmos and then looking for the vertex like I showed on that one example. And you can check, okay, does that number match the numbers that we calculated here? So that's a good way to check your work without going back and recalculating everything. It's a faster way to check your work. It can definitely save yourself some time on a quiz. Now, one thing that I did do in Desmos, so what I have here is you can kind of set it up if you're into programming. You can set it up where you tell it what your A, B, and C are. So I can plug in my numbers from our problem. And then what I did is I put our equation for our vertex, negative b over 2a, in here. And then I put the standard form. And so this would be, I mean, it doesn't matter if it's f of p or whatever here. It's just the standard form of a quadratic, and it uses those values, the a, b, and c that we have in our problem. And then it will calculate it for you. So if you're someone that really likes programming, you can even set something up like this in Desmos. You can create your own Desmos account, which is totally free, and you can save it. And then you can name it whatever you want. And so that can also be a good way to check your work on a quiz, is to like say, okay, I'm kind of doing it by hand, but then I just plug in my numbers and double check on the quiz if I got my numbers that I did from hand. These numbers are so big that they're not showing up on the graph, and we have to like really zoom out. And if you zoom out too much, it gets really flat, so you have to like adjust the window. But that doesn't matter. This is just a great way to check your work here. Are there any questions on this problem? Okay, so this is the one that I accidentally wrote on. So here's another good one. So we've got a long jumper leaves the ground at an angle of 20 degrees above the horizontal at a speed of 11 meters per second. The height of the jumper can be modeled by h of x equals negative 0.046x squared plus 0.364x. Just as an FYI, this equation that they're using here actually is based off of the physics equation. So there is an equation in physics for finding horizontal distance if you jump and you have a height and then you land. You know, basically a long jump makes a parabola shape. You've maybe not thought about it, but when you've got your distance here and they start and they basically they're jumping, they're running, and then they jump and they make that kind of shape. It's a parabola. And there's actually an equation in physics that takes the angle into the account, that takes gravity into account. All you need to know is your speed, and you have to have the right units, and you can come up with this equation. So this equation is a legit equation that you can come up as long as you know your angle, your speed, and your height at which you jump off. So just an FYI, this equation, and this is actually similar. It's the same type of equation that we're going to use in the week 7 discussion. Ours will be in feet per second and use like US units. So the equation looks a little different, but it's the same sort of thing. So they're giving us this equation. So h is the height. And so they use h to represent height, so that's why they pick that variable. And then x is horizontal distance, so that makes sense because if you look at your graph here, that would be your horizontal distance. So when we're looking at our problem, we've got at which horizontal distance from the point of launch does the maximum height occur? So that's okay, we're looking for the vertex. What is the maximum height of the long jumper? And then what is the length of the jump? So that's a third part here. So these kind of things, I always like to draw a picture and actually, maybe you can even draw a person here that they're running. And then you can even kind of draw them up in the air and then they land on the ground. You can get kind of creative about this. So first we want to find where the maximum height occurs. And so that is our vertex. So h is negative b over 2a. So to rewrite our formula bigger, we have h of x. And again, that's a different h. That's representing height. What some people like to do is instead of h here, they maybe just write x so that they know it's the x value that they're finding for the vertex, but they use the vertex formula. So that's an option. And then that's equal to negative 0.046x squared plus 0.364x. So we actually have no c here because it's starting in ground. So negative b, and b is the 0.364 divided by 2 times a, which is negative 0.046. So just pull out your calculator. And so I get lots of decimals, and I'm going to write down every single one that my calculator gives me. But we are going to, round. So it tells us specifically to round to 2 decimal places. And I see a lot of people tend to make mistakes rounding. So 2 decimal places means I want to cut it off where I've drawn the line. The rule is if the first number after the line is 5 or higher, then you round up. So because the number after the line is 6, this 5 is going to be rounded up to a 6. So we're going to use 3.96. Now, because this problem tells you to round before they get to the next part, for the part B, when we're finding the height, we can use the rounded version. If they did not tell you to round first before they gave you the next part of the question, you would use the full version. So because they told us rounded 2 decimal places, I can use 3.96 going forward. So k, the y value, or the height here, so we're looking at the height at a time of, or not a time, a distance of 3.96. So we're going to plug 3.96 in for x. So I've got negative 0.046 times 3.96 squared plus 0.364 times 3.96. So whether you just do that on your calculator or Desmos, it might actually take the same amount of time. I'm just using my calculator for now. You do want to double check what you're entering in, make sure there's no errors, because that's the biggest issue that I see is like you leave off a decimal place, or like instead of 0.046, you write 0.46. So always be very careful about what you're typing in. But I got 0.7200864. So hopefully you guys also did this and you got the same number. And so this one also says round to 2 decimal places. So I'm going to draw my line. And now the number that's after the 2 is 0. So it's below 5. So we don't need to round up, and we just use the same number, 0.72. So that is going to be the maximum height. And I would put these in sentences, but I don't have a lot of space here. So I'm just doing the number parts. Then part C says, what is the length of the jump? So that's where the picture comes in handy. So we just found the maximum here, and we found the distance. If we assume that this is, we start at 0, 0, then the x value of our vertex, 3.96, is going to be the same as the distance for the first half of the jump. So based off of the picture and how this works, that means the second half of the jump is going to be the same distance, 3.96. And these are, the units here are meters because it says the speed is meters per second. So I can put M as our abbreviation for meters, and then this is also meters. So then for the length of the jump, you're basically taking your vertex and multiplying it by 2. And this only works if you're starting at 0, 0. And if they don't tell you otherwise, you assume you're starting at 0, 0. So our length of jump is going to be 2 times 3.96. Which is 7.92 meters. And then it says to round to 1 decimal place. So I just want to have 1 decimal. So the number after that 1 decimal is a 2. It's below 5, so I don't have to round up. So we're going to use 7.9 meters. So if anybody is into the Olympics, which I think are still going to actually occur this summer, last I heard. Last I heard, the Olympics are still going on this summer in Japan. They do the long jump there. I'm a big Olympic fan, so now you can think about math when you watch the Olympics. They're like, oh, this is a parabola in their jump. Are there any questions? Okay. Let's see. I've got 2 examples. Which one do I want to do? We're not going to do the whole example here. I think I just want to show you how you set it up, because in this one, they're not giving you the equation. And this might be something that you kind of want to do, actually. So suppose that a family wants to fence in an area of their yard for a vegetable garden to keep out deer. One side is already fenced from the neighbor's property. So I'm going to just start by drawing a picture. And I'm just going to say, okay, let me just label it. That's the neighbor, their property there. So they want to have a fence, and we're going to have one side be the neighbor's property, probably an existing fence. And so we're looking for, if the family has enough money to buy 160 feet of fencing, what dimensions would produce the maximum area for the garden? So this might be something that you actually want to do. You want to maximize your gardening area. So I'm going to draw in the fence. And it's not telling us whether this is a square or a rectangle. So let's assume rectangle, and it may be a square. And let's say we use X and Y as our unknowns here. So I'm going to just label two sides are X. The third one is Y. So we need to create an equation before we can actually figure out the maximum area here. So we know that there's 160 feet of fencing. That is going to be the perimeter, because the fencing is going to be the length that we're doing here. So 160 is going to be X plus Y plus X. So we can simplify this as 2X plus Y. So that gives us one equation. And that's coming from the perimeter and the dimensions there. We don't know what X and Y are, but that's what the perimeter is giving us. So we just label perimeter. Then we can create another equation because we want to make the maximum area, so we need an equation for area. So area is length times width, which would be X times Y. So what we can do is take our perimeter equation that we have here, solve for Y. So if we solve this for Y, we'll get Y equals 160 minus 2X. So you would subtract 2X from both sides. Then we can take that equation and put it into our equation for area. So let's say, I'll do this in another color. So our area, I can use the letter A to make it a function. So it's going to be X times 160 minus 2X. So now I've got an equation, but in order to use the vertex formula to find the maximum area, I need to multiply this out. So we're going to distribute. So it's going to be 160x minus 2x squared. And to really put it in the right form, I'd put my x squared plus part first. So this is going to be negative 2x squared plus 160x. And so now we've got our formula. So now we can find the maximum. So it says what dimensions would produce the maximum area for the garden. Dimensions means that we're looking for X and Y. So I need to first find the value for X using the vertex, and then I need to plug that into this equation right here so that I can find Y as well. So first, our vertex is going to be negative b over 2a. So b is going to be 160. So this is negative 160 over 2 times negative 2. So just getting out my calculator. And I just typed that in wrong. So 40. So this is going to be 40 feet right here. And so then we can find the other dimension, 160 minus basically 40 and 40. And so that gives us 80 feet. So part A, we've got our dimensions. It would be 40 by 80 to get the maximum area for your garden. So it's not actually going to be a square that will get you your maximum. And my picture is totally not to scale. I've got the wrong side. My longest side that I drew was actually the shortest side. But that's okay. What matters is the numbers. So we've got the dimensions, 40 feet by 80 feet, and now what is that maximum area? So then we can just plug it into, and we want to plug in 40 because that's our value for x. And hopefully I'm not making any errors. 3,200, and then this is going to be feet squared because area is always squared. So it'd be 3,200 square feet for your, that would be the maximum area of your garden. So I can even write this. This would be 40 feet by 80 feet, and then 3,200 square feet. So this is a great example. This is something that you guys could use in your daily life. A lot of people tell me, well, why do we have to use this? Well, let's say you're a gardener. Here's a perfect example of how knowing algebra and actually understanding how this works can actually make your life easier versus just guessing and checking. I mean, yeah, probably most of the time you don't need to know the exact, but maybe you really care. You really want to have the maximum area because maybe you're going to sell your plants or something, so you want to make sure you can plant as much as possible. So this is how you would do it. You would actually have to use a quadratic equation, and then you'd be finding the vertex in order to find the maximum, and so that, and to find the dimensions so that you know where you need to have your sides and everything like that. So that way you know, okay, this is going to be the maximum amount of space that I can have. Are there any questions? All right, I definitely don't have time for my third example, but that's completely okay. You know, that could be something, if you want to do this one, you can. It's coming from 7.1, it's number 55. All of the answers to the odd numbers are in the end of the textbook, so you can always like try to do this one on your own. So this one's related to a gutter if you want to have the maximum volume, so you get the most water out of there. So another useful problem. So if you guys don't have any other questions, then you guys are free to go. I'll stop the recording.